Right. Good morning, good people. My name is Hendrik Makaneta. I'm going to teach you grade 7 mathematics. And I hope that by the end of this lesson, we'll be able to progress from the previous level where you were at to a better level now. Now, without any waste of time, just going to indicate that we need to be able to calculate again the surface area of cubes as well as cuboids. Now, this is the objective of today's lesson. At the end of this lesson, you must be able to calculate the surface area of cubes as well as cuboids. And this is a continuation from the previous lesson that we had. And of course, surface area, will mean that we are looking at the total areas of all the shapes when you have put it in the form of a net. Remember that a 3D object consists of 3 dimensions, namely the length, the breadth, as well as the height. And we call this the 3D object. The D, which stands for dimensional or dimension. So this is the 3D objects or 3 dimensions. And of course, those are geometrical objects. And the key explanation, if we look at the keywords there, we define a solid as a geometrical 3-dimensional object. So any solid is a 3-dimensional object. So in geometry, we call that a solid. And of course, a cuboid will be a rectangular solid with about 6 rectangular flat faces. And the cube is different from the cuboid in a sense that a cube consists of 6 square flat faces. So that is the difference between the 3. So you should know by now what a 3D object is. We say that it consists of the length, the breadth, as well as the height. So if you look at this particular 3D object here, it has got the length. As you can see, this is the length. That's the length of the object, our 3D object there. And of course, the breadth, you can see all the width, others call it the width or the breadth. And the last one is the height of the object. And those are the 3 components that complete the 3D object. The length, the breadth, and the height. And of course, if you look at other things, the top of the height there, this roof, the whole roof there is known as the face. This was a house, and the top there of the house, meaning that the roof, the entire roof there at the top is known as the face. And these corners, every corner there, where the 3 meet, in other words, where the length, the width or the breadth, and the height, where they meet, we say that corner there is the vertex. And remember, there is this corner of a hole here, this whole hole here, or the height. You see this height here. The corner there, which consists of, that is where also these things meet. The edge there is known as the edge. So you must distinguish between the edge and the vertex. The vertex form an angle. You can see that an angle is formed there at the vertex. But the edge, that is where the end of one hole, where you start a different direction now. Now, we've also spoken about the surface area of solids. We said that the surface area of any solid is the total area of the flat faces and the curved surfaces. And of course, we measure this in square units. And remember to always be able to convert. You need to be able to convert your millimeters to meters. And of course, the neck as well is defined as a two-dimensional shape that can be folded to form a 3D object. We are not going to waste time, but to reflect on the cuboid, to say there is a formula to calculate the cuboid. We have got a formula to calculate the cuboid, and of course, the formula to calculate the cuboid, we are going to use all of them, the length, the breadth, and the height. And we say everything must be multiplied by 2. Who can tell me why do we multiply everything there by 2? In other words, why do we multiply every area by 2? Because if you have got the face here at the top, there's also the bottom one. So those two are equal. Remember that even in a rectangle, the opposite sides of a rectangle are equal. So even in a cuboid, meaning that a rectangular prism, the opposite faces are equal. That is why when you calculate the area of the whole box, it will be the sum of all the areas of all the rectangles that are found in the specific cuboid there. So the cuboid and the rectangular prism, we're talking about the same thing. It's the same thing. There is no difference there. When you talk about the cuboid and the rectangular prism, you are talking about the same thing. And of course, the cube is different. How different is the cube from the cuboid? The cube is different because all the sides are equal, meaning that all the faces of a cube are also equal. That is the difference between the cuboid and the cube. So basically, a cuboid is derived from a rectangle, whereas a cube is derived from a square. So remember that in a square, we know that all the sides are equal in a square. So in a rectangular prism, not all sides are equal. You have one side bigger than the other. You have the length, the breadth, and the height. Although even in a cube you have those, the length, the breadth, and the height, but all of them are equal. The length is equal to the breadth, which in turn is equal to the height. That is in a cube. You've got the length, the breadth, and the height everywhere in a 3D object, as we have already indicated. But in a cube, the length is equal to the breadth, which is equal to the height. And of course, that is why when you find the surface area of a cube, you'll have 6 times length times length. Meaning that you'll have the area of each face there multiplied by 6. Remember, the area of a square is length times length. So that is why we've got 6L squared. L squared comes from length multiplied by length. You get length squared. Now, if we have to calculate the surface areas of these prisms, we can be able to see that the first one there, this one is a triangular prism. And we have already said that the triangular prism has got its own formula there, which we will come back to at a later stage. But for now, I want us to look at the surface area of the square, the cube. which is the base is a square, as well as the top is a square. The length of our cube there is 8 millimeters. The breadth is 8 millimeters. And the height is also 8 millimeters. What does this tell us? It tells us that we are now working with a cube, because in a cube, all the sides are equal. All sides are equal in a cube. Then you can use the same principle that we've used of calculating surface area. And we said that the surface area is given by the formula S is equal to 6L squared. And of course, this means to multiply the area, one of the areas there, by 6. Why by 6? Why do you multiply by 6? Who can tell me? Why do you multiply by 6 when you want the surface area of the cube? And that is because the cube, all right, Azania, let's go to Azania and hear your answer before we carry on. Azania, Noto?
You asked us why we can tell you why we have to multiply by 6, and then I said I wanted to say because there's 6 sides.
Yes, exactly. There's actually 6 spaces. Thank you very much.
6 spaces.
Azania. That's because there are 6 spaces. So Azania is correct. We have got 6 spaces in a box or in a cube. That is why we multiply by 6. Now, the L squared simply comes from the area of a square. And we said that the area of a square is length multiplied by length. And this is length squared, or L squared, L for length. Then we multiply that by 6 because there are 6 spaces in any cube. So even in this case, you do the same. You'll have length multiplied by length, which is 8 times 8, will give you 64. And thereafter, you multiply that by 6 spaces. In other words, that 8 times 8, which is 64, and then you multiply that by 6 spaces. So as you can see that the surface area here is 6S squared, and of course, this is 6 times 8 squared. 8 times 8 is 64, like I said, and 64 times 6 will give you 384. That will be your surface area. And that is the surface area for the cube here in B. That is the surface area for the cube. It's very easy. Very easy to work with the surface area for a cube, because all that you need to do is to multiply the length by the breadth. And of course, thereafter you multiply by the number of sides, or the number of faces actually. How many faces are there in the cube? And as we know, there are 6 faces. Therefore, you multiply the product of your length by the breadth. You multiply that by 6 faces. And then we come to the rectangular prism. Let's come to the rectangular prism there. Rectangular prism, with pillar, I can see that we have a length, which is 15 centimeters, as well as the breadth, which is 125 meters. And of course, the next one will be the height, which is 32 millimeters. That is the last one there, the height, which is 32 millimeters. So this particular 15 centimeters, that is the length. But as you can see, it is written in centimeters, not in millimeters. So before you can carry on, it's very important for you to convert so that you can work with the same unit of measurement. If you want, you can convert to centimeters. That is, if you want, you can convert everything to centimeters, or you can convert everything to millimeters. At this stage, the breadth is in millimeters, and the height as well is in millimeters. So if you want, like I said, you can convert it to centimeters. If you convert to centimeters, remember that you are dividing by 10. In other words, you will divide 125 by 10 in order to get 12,5 centimeters there. And you'll divide 32 by 10 in order to get 3,2 centimeters. And alternatively, like I said, you can convert to meters. To millimeters, sorry. Now, if you convert to millimeters already, this is 125 millimeters and the height is 32 millimeters. So meaning that all that you do, you will convert the 15 centimeters to millimeters. And how do you convert centimeters to millimeters? You multiply by 10. Remember that 1 centimeter is equal to 10 millimeters. So this means every time you convert from centimeters to millimeters, you simply multiply by 10. 1 centimeter, if you multiply that by 10, that is 10 millimeters. Very important. And of course, to find the surface area of this particular prism, the rectangular prism here, you are now going to use the formula that we have developed. In other words, you say that the surface area is equal to 2 multiplied by length times breadth, length times height, and breadth times height. So meaning that you will take the area of every face and then add them together. The reason why we multiply by 2 here is because every area has got is equal. Every face is equal to its opposite face, meaning that the top area is equal to the bottom one. And the side one, the sideways one on the right hand side is equal to the one on the left. And of course, the opposite one will be equal to the one at the back, because you've got an area there of 6 faces. So whether you are working with a cube or a cuboid, both of them have got 6 faces. And of course, this means that to find the area of this C here, you just have to use the formula. But if you cannot use the formula, remember, you can find the area of each and every face, and then you thereafter add them together. So using the formula, you can see that the other thing that we needed to do was to convert the centimeters there to the 15 centimeters and multiply by 10. And if you multiply 15 by 10, you get 150 millimeters. Of course, L is equal to 150 millimeters, B is 125 millimeters, and the last one there, which is the height, is 32 millimeters. Then you can put that in the formula, get the area or the surface area of 55,100 square millimeters. So that is how you proceed in calculating the surface area. Now, remember, as we have said, that the surface area of any 3-dimensional object is the total area of all the faces of the object. So you add all the areas. You take the object and you look at each and every face, then you calculate the area of that face. And if you add them together, they will give you the surface area of a three-dimensional object or a 3D object. Please note that 1 square meter is the same as 100 centimeters multiplied by 100 centimeters, which in turn will give you 10,000 square centimeters. And of course, 1 square centimeter there will give you 10 millimeters multiplied by 10 millimeters, which is equal to 1,000 cubic millimeters. So to get 1 cubic, that is the volume there. The last one was the volume, but the square, 1 square centimeter will be equal to 10 millimeters multiplied by 10 millimeters, which is 100 square millimeters. And I hope that you don't forget how to convert from millimeters to centimeters. So you can see we have an example here of a rectangular prism. And of course, this side here, or the top one there, is known as a face. This side. That's your face. And this one in the corner here, which forms an angle, we know it's known as the vertex. And then that line there is known as the edge. So basically, a cube is a rectangular prism with 6 identical squares. There's a difference between a rectangular prism and a cube. A cuboid is just known as a rectangular prism, but a cube is also a rectangular prism. Because remember that a square is also a rectangle because it has got a length and a breadth, although they are equal. So a square is the same as a rectangle. It has got the length and the breadth, but they are equal in that case. So the surface area of a rectangular prism can define it. If you don't want to use the width or the W there, then you can use B, the breadth. And of course, if you don't want to use the length, you can use the side. In the cube, find the sum of the areas of all the faces there. And this means that 6s squared will be the total surface area. Now, the linear dimensions are expressed in the same manner. You've got L, B, H, S, and H. They must be expressed in the same way, where L is the length, B is the breadth, and H is the height. And of course, side S can stand for the side. The other H there is the perpendicular height, so it's different from the normal H. It is not necessary really to memorize the surface area formula. You don't have to memorize it. All that you have to know is to know how to derive it, in fact. You need to know how to find that formula. Do not memorize it. Find a way to find or to develop the formula for the surface area. And how do you develop this formula? You simply add all the areas of all the faces. There are 6 faces. Each face has got its own area, length multiplied by breadth, and so on and so forth. You have to multiply to identify in your cube what is the length, what is the breadth, and what is the height. If it's a rectangular prism like a cuboid, again you identify the length, the breadth, and the height. Once you have identified those, then you can be able to find the area for each side or for each face. Then if you add all of those areas together, you see that it will give you the formula to calculate the surface area. So the surface area is the total, or is the sum of all the areas of any object. Now the first one there, as you can see, we have to now determine the area of this cube. The cube has got the length of 20. And as you know, all sides are equal in a cube. So basically, in a cube, say SA, which is the surface area, is equal to 6L squared or 6S squared. So S stands for the side, L stands for the length. So you can use L or S, it doesn't matter. So the area there will be 6S squared. And of course, as you can see, it becomes 6 multiplied by 20 multiplied by 20. Remember that your side there is 20 centimeters. 20 times 20 is 400, and 400 times 6 gives you 2,400 square centimeters. So this will be the surface area of the cube. You are told that the dimensions must be in centimeters. And of course, that is what we get. The surface area of this particular cube would be 2,400 square centimeters. That is what it is. How did we find that? We have multiplied the length by itself, so that will be 20 multiplied by 20. And thereafter, you multiply everything by 6, because there are 6 sides or 6 faces of this cube. It's the same as adding all the faces. Add all 6 faces. And because the sides are the same, then that is why you just say you multiply by 6. Because in any case, area of each and every side in a square there will be equal in this. Now let us go to B, where we must find the surface area of this 3D object. Now, what is the difference between this object here and this one? Maybe you can tell me the difference. Do you spot the difference between this rectangular prism and this other rectangular prism? Two of these. Do you spot the difference? What is the difference? Who can tell what is the difference? Yes, Amo.
So, can you hear me?
Yes, I can hear you.
The difference is that the faces are not the same length. With the faces are not the same lengths.
Thank you very much, Amo. The faces are not the same, do not have the same length. To qualify what Amo has just said, we can conclude that in B, in the rectangular prism here in B, as well as the prism in A. In A, all sides are equal, whereas in B, all sides are not equal. Now, where all sides are equal, the surface area becomes easy to calculate, because you just calculate the surface area of just one face. And once you have done that, you multiply it by 6, because all the faces there are equal in a dimension of that way, in this 3D object. Once you have got the length equal to the breadth, which is in turn is equal to the height, and you know you are working with a cube, and you also know that the area of every face there is equal to all the areas, or each and every area of the face, they are equal there. That is why you can just take one area of one side, and then you multiply that by 6. Unlike here in B, you cannot do that there. You cannot apply what you have done in A in B. B is different. And the difference is, in B, as Amo has just correctly said, you have the length, which is 18.2 centimeters there. Then you also have the breadth, which is 7.8 meters. Then you also have the height, 10.5 centimeters. This is where the formula to calculate the surface area of a prism, a rectangular prism, comes in. And as you know by now, we have said that the formula to calculate the surface area of a rectangular prism is given by 2 open brackets. Then you've got the areas of each and every face or one of the faces. Remember that in a rectangular prism, the opposite sides are equal. The opposite faces are equal. Therefore, you take the area of just one face there and then you multiply it by 2. Because the opposite is equal to the original face. That is why you multiply that by 2. Now, 2 times HL, 2 times LB, 2 times BH. Take 2 as a common factor there. You've got 2 open brackets. Then you take each area there, you plus it with the next and the last one. And then of course, that will give you the surface area. As you can see, even in this case, that is what we have done. We have agreed that the length is 18.2, the breadth is 7.8, the height is 10.5. Then of course, you will be able to find that this gives you 829.92 square centimeters. That will be the surface area of this rectangular prism. And then, of course, the last one, which is C. You can see that the length and the breadth are equal. That is the last one there. Length and breadth are equal. The height is the only one which is different. Again, it's only 2 things that are equal there, the length and the breadth. But the height is different, it's 53.3. So you cannot apply the same method that you have applied in this cube there. Because not all 3 sides are equal. So the length is equal to the breadth, but both of them are not equal to the height. The height is different. But if the height was also 45.6 in this case, if the height was the same as the length and the breadth, then we're going to conclude that these two cube, we're simply going to multiply the area of one face by 6. But you can't do that because the height is not the same as the length. Hence, you need to use the formula to calculate the surface area of the rectangular prism. And of course, you will be able to use that surface area. You can see that the length is equal to the breadth. And this in turn is equal to 45.6. And the height is 53.3. And once you have put all the unknowns into the equation, this equation here, then you will be able to find that the surface area of that particular rectangular prism is 13,880.64 square centimeters. That will be the surface area. Now, I want us to focus on the following, where we must calculate the surface area of the 3D object. Consider the 2 3D objects there. And as you can see, the first one there consists of, you know, 3 equal sides, meaning that the length is equal to the breadth, which in turn is equal to the height. And the bottom one, the second one there, you only have the length and the breadth equal, but the height is different. So in the first category, you can simply use the formula for the surface area, which is 6L squared or 6S squared. And then, of course, this means you can just take the area of any of the sides here, then you multiply that by 6. That's how you're going to find the area of D. And the area of E, you cannot use the same approach in D because not all sides are equal. In this case, all sides are equal, therefore this is a cube. When all sides are equal, we are talking of a cube. You are just going to multiply 87 by 87 to get your surface area. But thereafter, you don't end there. You multiply 87 by itself, and then you multiply the product by 6, because there are 6 spaces there in a cube. Whereas in this case, you just have to calculate the area of each and every face, and thereafter you add them together in order to find the total surface area. That is how we proceed as far as these two are concerned. As you can see in the first category there, we have surface area. SA stands for surface area, which is equal to 6S squared. And as we know, the value of the site is 87 millimeters. That is the prism that we're talking about. Rectangular prism here, where the arrow is now. We are calculating the surface area of this prism. Also known as the rectangular prism, but this one is a cube because all sides are equal. And as I've said, you multiply 87 by 87. And thereafter, you multiply the product by 6 spaces here. This stands for 6 spaces of the cube. And the answer that you will get will be 45,440 square millimeters. That will be the answer for the surface area of the cube. And to find the answer for this rectangular prism surface area, again, as I've said, the opposite sides are equal. Therefore, the area of this face here, you multiply it by 2. The area of one side, you multiply that by 2. The area of the other side, you multiply that by 2. And this will give you the sum or the total area, surface area of this particular cuboid. Alternatively, you can use the formula. And once you use the formula, it should be clear that the length is equal to 5 meters. The breadth is also 5 meters. But the height is different. That is 13 meters. We're talking about this particular prism here. As you can see, the length is 5. The breadth is also 5, but the height is 13 meters. Of course, once we have used the formula, it becomes clearer that your final answer will be 310 square meters. That is if you have substituted correctly. Length times height. So this is length, so it's 5 times height. So you have 5 times 30. And then length times breadth. Length is 5, breadth is 5, so you've got 5 times 5. Plus breadth is 5, height is 13. Then you've got 5 times 13. And of course, if you multiply 5 by 30, you get 5. 5 times 5, 25. 5 times 13, 65. You add 65 and 65, they give you 130. 130 plus 25 gives you 155. And of course, if you multiply that by 2, you get 310 square meters. And that will be your surface area for the rectangular prism. This actually brings us to the end of our lesson. But just to recap once again, on the surface area, it's very important to know that the formula for the surface area can be derived by yourself. And how can you derive it? Even when you are given this box here, or this rectangular prism, you know that to find the area of this side, or the bottom one, let's talk about the bottom area, or the top one, because the bottom face is equal to the top face. Now, how do you find the area of that face? By simply multiplying length times breadth. And because the bottom face is equal to the top face, you add 2 times of those. 2 times length times breadth. So we have 2LB. And the other one, the right hand side, that will be B times H. It's equal to the left hand one. That is why you have 2BH. And of course, the last one there will be the height and the length. And then it's opposite to, it's equal to the opposite side, and then that is why you have 2HL. And if you take out the common factor of 2 there, that's how you are left with this particular equation of the surface area. And of course, the easy one, as I said, is the one where you have the cube, where all sides are equal. The length is equal to the breadth, which is equal to the height. That's why you can simply take the area of one side and multiply it by 6 when all the sides are equal, and that will give you the surface area. I think that is the most important aspect of rectangular prisms, a cube or a cuboid. The cuboid will be a rectangular prism in the true sense of the way, in the sense that the length will not be equal to the breadth, and of course the height might also be different. But at times, you can have the length which is equal to the breadth, but the height will be different. That will be the rectangular prism known as the cuboid. But in a cube, all the sides will be equal. In other words, the length is equal to the breadth, which is equal to the height. So please distinguish between the cube and the cuboid. The cube and the cuboid. I hope that it helps you to carry on to do your various activities. I hope that this lesson will be able to help you, particularly the examples that we have had where we were determining the surface area. Remember, up to now, we have done the area of 2D shapes. You know how to calculate the area of a 2D shape. So this is the next work where you need to do the surface area. The surface area is done in 3D objects, but in 2D shapes, you use the normal area. You know how to calculate the area of a rectangle, the area of a square, the area of a triangle. We have done that in this school already. But equally, we have also done now the surface area of 3D objects. In particular, we have focused on 2 3D objects being the cuboid and the cube. And I think that this lesson will certainly go a long way to help you. Please continue to visit some of these video clips which are put on the board Just for additional help, of course, we have looked at the various properties of 2D shapes as well as 3D objects. For any further information or for more clarity-seeking questions, please feel free to also visit us in our pages. We've got our social media pages like Twitter at Africa Team Geeks. That is where we are. We are also on Facebook. Of course, this lesson is brought to you by the Lockdown is School partnership with our funders, the Sasol Foundation, as well as the STEM Champions, together with the DBE and MS Zora. Until we meet again tomorrow in our next lesson, thank you very much indeed for taking the time to also participate.